So let's start our next section. We're going to be in 11.7, which is about cylindrical and spherical coordinates. So the idea is we so far have worked with rectangular coordinates. So when we do x, y, and z, right, and then we graph, here, this is the coordinate system that we've been working with so far. But there are other coordinate systems we can work with, and we're going to talk about cylindrical first. But before I do that, I briefly want to discuss polar coordinates. You may or may not be familiar with them. So back in our two-dimensional world, right, we have rectangular coordinates. So x comma y. But then we have polar coordinates, and we can represent a point not as x, y, but instead if I have a point, so here's my point, before we represented it with this distance x and this vertical distance y, but now I represent this point with the distance from the origin, we call that r, and then the angle between that line segment and the x-axis, and that's called theta here. So we represent a point in polar with these coordinates r comma theta. And we can use our trig. If I drop down here, form a right axis, I can now relate x and y to r and theta in the following way. So I know that cosine of theta, it's adjacent over hypotenuse, which is x over r, and sine theta is opposite y over r. So you can solve for your two variables. X is r cosine theta and y is r sine theta. So basically what we're going to do now is we're going to talk about cylindrical coordinates. And you can think of it as being an extension of this idea of polar coordinates, but for 3 dimensions. So in cylindrical coordinates, we're going to say a point in space is represented by the triple. It'll be r, theta, and z, where r theta is the polar representation of the projection of the point in the xy plane. So let me give you a visual picture to kind of represent what I'm saying here. You have a point in space, and what you're going to do is project that down onto the xy plane. So imagine you're holding a light above it and drop it vertically down to the xy plane so that now its coordinate is xy 0. And then because I'm in the xy plane, I can talk about r and theta. So r would be the distance from from the origin to this projection. So that distance right there, this would be r, and this angle here would be theta. And the z-coordinate is just the same z-coordinate that it had before. So then we have two different coordinate systems, and we need to know how to convert between them. We need to communicate effectively between us. So if somebody's working in cylindrical, somebody's working in rectangular, we need a way of translating those coordinates. So how do I get from cylindrical to rectangular? Already talked about it. X equals r cosine theta, y is r sine theta, and the third coordinate is the same in both systems. So right here, this is how I convert from cylindrical to rectangular. And how do I convert the other way from rectangular to cylindrical? Well, you're going to have r squared. It was a right triangle, so r squared is this equal to x squared plus y squared. If you go back to that triangle, you'll see that tangent is y over x, and again, the third coordinate is the same in both systems. So there's my way to convert from rectangular to cylindrical. So now that I have these conversions, the next thing we're going to do is we're going to convert some points between these two systems.